Okay, so this is a question about vectors forming a parallelogram. Now, from part A of the question, we already know that P to S is two lots of A. From P to R takes two lots of A plus a B. And we also know that M to Q is going to be equal to going backwards along an A and forwards along a B, so minus A plus B. What we want to do now is to create a point N on the line MQ 1/3 of the way along and show that P through N to R is a straight line. We want to do that using a vector method. So the first thing to look at would be the vector Pn. So what would the Pn look like? To get from P to N, we go from P to M and then 1/3 of the way from M to Q, because we know that 1/3 of MQ is what Mn is. Now if we write that in terms of A's and B's, Pm is just A, and then we've got 1/3 of MQ, and we know that MQ is negative A plus B from our work in part A. Next we want to multiply out the brackets. And then we're going to collect together the like terms. So we're going to collect together the A's. Now what we need to notice at this point is that this is actually 1/3 of the vector PR. PR was 2A plus B. We found it in part A. And so 2/3 A plus 1/3 B is just 1/3 of that. So if Pn is a part of PR, and we know from our working that it's 1/3 of it, if Pn is a part of PR, then P through N to R must be a straight line.